All right. Hello, API Days Melbourne. My name is Peter Marelas. I am the Chief Architect for New Relic. And in this session, I'm going to talk about how we built our generative AI assistant, which we call New Relic Grok. Now, before I talk about the actual assistant itself, I have to give you a little bit of background about New Relic and the New Relic platform. So we are a cloud-based observability platform. If you don't know what observability means, just think modern monitoring solution. Essentially what we do is we collect data from a bunch of different devices within our customers' environments, so cloud environments, software, uh, mobile applications, and websites. Then we actually store all that data within our New Relic platform, where we analyze it for our customers. So we look for correlations and trends and anomalies. And then we visualize that data. So we allow our customers to visualize that data to understand the health of their environment, the performance, the relationships between different devices and software, and so forth. So that's the New Relic platform. Now, what was our motivation to build that generative AI assistant? So one of the challenges we have with our platform is it's been around for over a decade, and we've amassed about 30 different features. And we have a lot of customers often ask us, how do I do something within the platform? Because it's easy to kind of get lost. And we know that, if you try and use keyword-based search engines and you ask like a how do I question, you typically get not a very good response. We also know that with ChatGPT, it's actually really good at answering these how do I questions. And so what we wanted to do is bring that sort of ChatGPT experience directly into our platform so customers can ask specific questions about our capabilities and information within our documentation. The second motivation is we also have a query language within New Relic. We call it NRQL. And customers use this to answer different questions about their data. So for example, I'm asking the question here, what was the transaction count over the last week for each transaction? And the problem is this language it's actually a dialect of SQL. It's not the full ANSI SQL. And so if you haven't been exposed to it for a while, then sometimes there's a bit of a learning curve to learn it. And then secondly, behind the language is an actual schema with lots of different tables and lots of different columns, and customers don't always know what these tables and columns actually mean. And so, we wanted to bring this learning curve down with generative AI. And then the last motivation is, generative AI is at the peak of the hype cycle at the moment, and this really creates expectations with customers. So our customers, they've been asking us how we're actually going to apply this technology to our platform to improve their user experience. So we thought this was a great opportunity for us to jump on board and start experimenting with this technology. Now, before I tell you how Grok was built, let me show you what it actually looks like. So this is the New Relic user interface. This is what you see when you first log in. And to access Grok, it's simply a matter of clicking a button on the top right. And what we do is we actually open a side panel over the window where now users can interact directly with Grok. So that's what Grok looks like. Let's now talk about what Grok can actually do. So Grok has 4 skills. The first is able to answer questions about New Relic capabilities, about New Relic features. And what we do is we leverage the documentation to answer those questions. The second thing is Grok can answer questions about the user's data. And what we're doing here, we're actually translating the question into a query, then we execute that query against the user's data in our database to respond to that question. The third thing Grok can do is it can check for anomalies within a customer's environment. So you can ask a question like, are there any problems within the environment? And what Grok will do is it will go and interface with APIs and our database to detect if there's any current issues within the environment. And then the last thing Grok can do is it can interpret a user's dashboard. So it can tell you what that dashboard's telling you and the information that it contains. The way that Grok achieve these 4 skills is each one of these skills has an actual tool that Grok interfaces with, and that tool then interfaces with data sources to answer the question. So let me show you Grok in action with some of these use cases that I just talked about. So in this first example, I'm going to ask Grok a simple question: how do I instrument AWS? And so what Grok is doing in this scenario, it's actually drawing this information from the documentation using the documentation tool to answer the question. And what you see in the end result is a nice response where you've got concise information about this particular question, but then you've also got links back to the documentation if the user wants to investigate further. Another example here is Grok can answer questions about a user's data. So here I'm going to ask the question, how many failed transactions did I have today? And what Grok actually knows that this question is about a database query, so it actually has to perform a database query to answer this question. And so it translates the question into a query. It then executes the query and it renders the results in the screen, both visually and using a natural language response. So in this case, in this particular example, there were 97 failed transactions today. And then in another example, we're going to ask a general question, are there any problems within my environment? And so again, Grok knows that to answer this question, it has to talk to our anomaly API, query that API, and then look for any current anomalies, and then respond back to the user, with a great deal of detail of where those anomalies are, and also links into the dashboards where the user can investigate further in relation to those anomalies. And the final example I'll show you is here I've got behind Grok, I've actually got a simple dashboard, and I want to actually know what this dashboard is telling me. So I ask Grok, what is on this dashboard? And what Grok is doing here is actually interpreting the configuration of the dashboard, but also the data that's contained within that dashboard, and it's providing insights about, what is this actually dashboard telling me, and how should I interpret the results. And it does this pretty quickly in an instant. So that's what you can do with Grok at the moment. And the first question you've probably got is, how does Grok decide what skill or what tool it needs to use to answer a particular question? And so for that, we actually ask a large language model to decide which tool to use to respond to a particular question. And the way we achieve that is we actually guide these large language models. We give them a description of the tools and the skills that each tool can perform. And then we pair that with previous questions and tool selections so that it can draw on that sort of past experience and make sure that it matches the right tool to the right question. And then based on the decision that the large language model makes, we route the request to that particular tool. And so this is really the easy bit, and this is the beginning of every conversation with Grok. Now let's look at how Grok actually processes a request to translate natural language to a NRQL query. So the first thing we do is we actually ask the LLM, the large language model, to pick the most relevant tables for the user's question. And so to actually answer this question, we give the large language model the original question and all the tables that that particular user has access to. And then we basically ask the LLM, which is the most likely table that's going to answer this question. So we want to narrow down the number of tables that we need to process. The next thing we do is we'll go get all the schemas associated with those tables and the metadata. So think of like all the columns and the column descriptions associated with those tables. Then we actually go and retrieve similar examples of questions and queries that are associated with those types of tables. And we draw all these examples from a vector database where we store all this information. Then we combine all the metadata all the examples and the original user's question into the prompt, and then we send it to the large language model, and we say, please generate a local query to answer this question. And then it comes back with a query. We'll validate the syntax of that query. Then we go and execute that query, take the responses, send them back to the large language model, and ask it to generate a natural text response. And then we just display everything on the screen, along with the charts and the natural language response. So what you might gather from this entire process is it's actually quite involved. So we're literally interacting with the large language model 4 times to process one natural language expression to translate that into an actual NRQL query. Another way that Grok works is it able to answer questions from our documentation. So the process it uses for this is a lot less involved. The way it works is we actually convert a question into what's called embeddings. And embeddings is just a high dimensional vector that represents that particular text. But the special property associated with embeddings is the text that is semantically similar, has a semantically similar meaning, gets stored close together, right? And so why does this matter? Because we want to be able to search vector database for these embeddings, and we want to draw out documentation that is related to those embeddings. And in particular, we want to draw passages from that documentation related to the embedding. And then what we do is we generate a prompt with the original question and all these relevant passages. So we stick that all together, then we pass it to the large language model, and we ask it to answer the question using the passages that we passed into it from the prompt, right? This approach is actually quite common these days. It's actually called, well, in-context learning with retrieval augmented generation. And so the key here is actually we pass the large language model the context it needs to use to answer the question. All right, so that was a brief overview of, Grok and how Grok works. So let me now talk you through some of the challenges we faced and how we've overcome these challenges. So if you're going to build a domain-specific assistant, it's important to recognize that we have to use these large language models in a certain way. So let's think about, what do we actually want from an AI assistant? The first thing is we want it to be able to interact using natural language instructions, right? The second thing we want is we need it to be able to actually draw from specific knowledge databases, right? This is maybe specific domain knowledge, about your company or your customers. Third, we want it to actually implement specific rules. These rules may be specific syntax within your application. For example, NRQL queries have a specific syntax. We need to conform to that syntax. Then we also need it to support general output formats, right? So we want it to be able to generate things like Markdown and HTML. And last, and probably the most important, is that the output that the assistant generates, we actually want that to be deterministic. We don't want it to answer the same question 3 different ways. Now, what we actually get with these foundational large language models like OpenAI is we actually get a generic knowledge database, right? Because these models are trained on the entire internet. And the problem with that is sometimes it can contradict with our domain knowledge, right? For example, the knowledge in these models can be predate today's knowledge. And so that's a problem. The other problem is these models, they implement generic rules, right? And generic rule interpreters. And again, these might interfere with the rules we want to enforce. So in our example, We don't want the model to confuse NRQL syntax with SQL syntax because they're not the same. And then the third issue is these models produce creative output, which is actually not what we want. We want the output to be deterministic, because if you're using these assistants, if you're a user and you ask the question, you get different responses, then you might start to lose trust in the actual assistant. And so the bottom line is, when we build a domain-specific assistant, we actually want a specialized assistant. We don't want a generalized assistant. And so what do we do about it? So in practice, we have to supplement the foundational models with the information that it's actually missing, right? We need to give the models access to specific knowledge databases about your organization, about your processes, about your customers, about your data. We also need to give it access to specific rules, right? So that it doesn't get confused with the general rules that it understands. And the way we do that is by putting the knowledge and the rules into the actual prompt. So when we do that, what happens is the prompt actually biases the model to specialize in your domain. And that's really important because it allows the model to produce relevant responses and more deterministic results. Now, I won't say that this approach is, foolproof or perfect, because these models are fundamentally probabilistic in the way that they generate output, so they can't be entirely deterministic, right? And that's why I have the asterisk there. But it is better to use the models using this approach than just use them as vanilla foundational models. The second challenge is we need to know what questions our users want to ask, right? If we're going to build an AI assistant, we need to know what questions we need to answer. And so the solution we used and we found is to just announce the assistant early, right? We announced the feature, I think it was back in, it was either March or May, and that attracted a whole bunch of users to sign up to early previews of the feature, and then we actually performed a user study. And what we did is we just asked the users, what questions would you like us to be able to answer with our AI assistant? And so what we found is 79% of our users want to learn something about a capability within New Relic, or they want to be able to get insights from their own data. And so this really helped us prioritize the tools that we actually need to develop first and the types of questions that we need to answer first and answer very well. Now, another challenge you'll face, and particularly in the beginning, is finding the right prompts to guide the model. What we've learned is these prompts need ongoing refinement, right? Because you'll find edge cases as your users start using the assistant and start giving you feedback on the assistant. So for example, your users will try and break out of the prompts to make the model do things that it shouldn't, right? And answer questions that it shouldn't. So you really want to bias the model to perform a specific role. And so what you see here on the top left is actually our system instruction for translating natural language to NRQL queries. And what you see is we have to be very specific. We're basically saying you are an AI assistant specialized in translating user questions into New Relic query language with no knowledge of SQL, right? So we, over many iterations, we realize this is really how we need to, this is the prompt we need to bias the model to only answer questions relating to the NRQL language. We also found you really have to feed the model examples of similar questions and answers. So every time you ask it a question, you have to draw on some prior knowledge, let's say a vector database, where you pull out examples of similar questions, similar answers, and then you need to seed the prompt with those examples in addition to the original question. And what that does is it calibrates the model to do the right thing. in our case, we actually seed anytime we ask a question about a query, we actually seed the prompt with 15 examples. And so this technique is called few-shot prompting. We also have to add rules to the prompt so the model doesn't get confused with concepts in its base knowledge that it's learned from the internet. So again, we have to add rules like, you should not respond with SQL. Because it can get confused. And the other thing is you really need this from day one. You actually need a feedback mechanism to measure positive and negative sentiment for each and every response that your assistant generates. Because if you think about it, you're constantly refining and changing the prompts, and so the way that the models behave is going to change as well. So you need to be able to detect when the quality starts to degrade or starts to improve. And then the last thing you're going to need is a robust test harness. I don't have a lot of time to talk about this, but there's two metrics you can use to sort of unit test the responses. One is Rogue, and the other is BERT score. So definitely look into those. Another challenge is performance. So LLMs can be pretty slow, and they can also yield high variance. And the reason, my guess is, is there's more demand than supply, and there's not enough GPUs to run these models as it stands. So these are some real world latency figures from New Relic Grok. What you see here is the median time to intermediate token is 4 seconds, 11 seconds to the first token, and 31 seconds to the last token. And this is not a small amount of time for someone to wait for a response from an assistant. And so the way we deal with this is we actually emit intermediate messages so the user kind of knows that the request is progressing in the background. Another two things we do to improve performance is we distribute requests to multiple endpoints. That allows us to reduce the variance and also avoid rate limiting. And the last thing we do is we'll cache some of the answers, particularly those related to documentation. And the last challenge is cost, right? You're going to need to figure out how to pay for it. These LLMs get really expensive very quickly. We're currently using the 8K context GPT-4 models. We're also going to start using the 32K context, which are even more expensive. And so if you think about how these models actually charge, they charge based on the amount of text going into them and the text going out. And so when you use LLMs with in-context learning, the cost per request starts to add up very quickly, right? Because the size of the prompt is directly related to the cost of each request. And so in this particular example, we've modeled here 100 users performing 10 requests per day adds up very quickly, right? You're looking at around $4,900 a month, which is, quite substantial. And so that is where we are today with Grok. We are about 6 months into our development. Some of the things we're looking at developing next is one is we want to continue to improve the quality of responses by refining our prompts from feedback that we get from customers. And then now that we actually have data from our early users, we want to start experiment with our own models. So we want to start fine-tuning our own models. And that will allow us to improve the quality of the models and also reduce the cost. And then the last thing we're working on is we're developing new skills for Grok. So one of the areas we're looking at the moment is to be able to translate natural language instructions into actual configurations and then, allow customers to configure their New Relic environments with just natural language, which I think will be pretty cool. So that concludes my talk. I hope you enjoyed it. If you want to get in touch, there are my details on the screen. Happy to connect or on LinkedIn or chat online. You'll see me tomorrow at the conference. Thanks very much.